Hi everyone, I'm Cheryl. In this problem, we're going to be looking at the function f of x equals x squared times the quantity 4 minus x squared. We're going to determine whether this function is even, odd, or neither. Then we're going to find the zeros of the function. And finally, we're going to use a graphing utility to help verify the results. Okay, so let's go ahead and get started. First of all, is this function even or odd? Well, to determine whether a function is even or odd, we're going to replace all of the x's with a negative x. So f of negative x is going to equal negative x squared times the quantity 4 minus a negative x squared. Now let's see what this does to my function. Negative x squared is just x squared. And in a similar way, the negative x that is squared in this location is also just x squared. So I have x squared times the quantity 4 minus x squared. Notice that this is exactly the same thing that I started with, which indicates that my function is even. Now remember what even means. Even means symmetric with respect to the y-axis. Okay, now we're going to look for the zeros of a function. Well, what are the zeros of a function? The zeros are the location where f of x equals 0. So let's start out with f of x being equal to 0. So that means that x squared times the quantity 4 minus x squared has to equal 0. Well, I need to solve this equation for 0. And I think what I'm going to do is I'm going to factor that expression 4 minus x squared, so that I have x squared times the quantity 2 minus x times the quantity 2 plus x. Now notice what I have. I have 3 factors multiplied together that equal 0. In order for things that are multiplied together to equal 0, one of them has to be 0, which means that either the x squared is 0, the 2 minus x equals 0, or the 2 plus x equals 0. Solving for x in each of these situations, I end up with x equals 0, x equals 2, and x equals negative 2. So the zeros of this function are negative 2, 0, and 2. Now let's go ahead and use a graphing utility to verify my results. Now a good window for this particular function is going to be from negative 5 to positive 5 with a scale of 1 on both the x and the y-axis. And if I enter x squared times the quantity 4 minus x squared, and then graph my function, I'm going to make a couple of observations. First of all, it is indeed symmetric with respect to the y-axis, which is exactly what I found out when I determined that the function was even. And I also notice that this function crosses the x-axis in 3 locations. It crosses exactly at negative 2, 0, and positive 2. Exactly what I found when I found the zeros of my function. I hope that was helpful. Thanks.